Okay, I wanted to crank through a couple more examples of using the limit definition of derivative. We'll start with another one of these, which isn't that bad. It's just getting used to the process. And then I'll do one that's a little worse. So this one, I just want to show you, the different ways you could be asked how to do this. Like, I can say use limit definition of derivative to differentiate, find d over dx of f of x. These are all just ways to tell you to find a derivative. There are just tons of synonyms for this. Now, if I start with f of x, my answer better be f prime of x. Okay, that means the derivative. All right, so let's do it. Let's do it. Here's the limit definition of derivative. You basically write this down every time, and then you plug stuff in. And you don't mess up the math along the way, and you'll be good. What am I finding every time? An equation that finds the slope of this crazy curve at any point I want. Now this will be a different answer than last time. Okay, so let's do it. Okay, first things first, I'm going to plug in, actually, I'm going to do this in reverse order. I'm going to make this a pretty big line, but I'm going to write down the easy stuff first, like delta x. And then the second easiest thing to write down is this guy, minus f of x. I'm going to put it way back here because I don't know how long it'll take to write the other one. So I'm going to do minus f of x, which is this whole ugly thing, x squared plus 3x minus 1. Cool. Now what goes in front? The worst part, which is f of x plus delta x, which means I'm going to go through this equation, and everywhere I see an x, I'm going to plug in x plus delta x. Just like if I would have had a 5 there, I would have plugged a 5 in here and here. Okay. X plus delta x, and then I still have a minus 1. Okay, so here is the first part. There's a minus sign between them. Here is the second part where I just copy that down, and I still have the delta x on bottom. So if you are good at setting this up, you're kind of going to be okay as long as you don't mess up the algebra. So now it's algebra time. Okay, I got a few things to do. I have to distribute this 3 to both those pieces. I have to distribute this negative sign to all 3 of those. The negative one's kind of chilling out, and I have to square this guy. Now, hopefully, you're going to do this enough times that you better just get used to how to square this. And by the way, if my problem would have started out with a cubed, I would have to know how to cube it. And if it would have started out with a 4th power, I would have to know how to 4th power it. I have a handy way to do that. But this is always first term squared, and then it's 2 times first term times second term, and then it's last term squared. Every time. If you didn't get that, that's what this guy turns into. If you didn't get that, then, you could do it the slow way. Just write it out twice like last time. Check out the last video. And you'll see. So I FOILed that out. I distributed the 3 to both those. I still have a minus 1 chilling out here. And then I'm going to go minus x squared, minus 3x, and plus 1. All over delta x. Now what's good is stuff starts to cancel. And you know how I told you, like, everything at the back should cancel. That means if I see a plus 1, it should cancel with a minus 1. If I see a negative 3x at the back, it should cancel with a positive 3x. And if I see a negative x squared, it should cancel with a positive x squared. If something didn't happen, then you FOILed wrong. You distributed wrong. Something bad happened with your math work. You made a rookie mistake. Now, what's left? 2x delta x, a delta x squared, a 3 delta x. What you should notice, and it's a good thing, if everything you have left has a delta x in it, that is a great thing, because my last step, since it made 0 over 0 this whole time, my last step is to divide each piece by delta x. So I'm killing off a delta x on bottom, and I'm killing off 1 delta x from each of the terms. So what's left when I'm done killing off those delta x's is 2x, delta x, and 3. See how it went away? And now I can plug in a 0 for delta x, and I get 2x plus 3. Which means if my original equation started out being called f of x, and it's a parabola and all that stuff, then this equation means f prime of x, 2x plus 3. And what this is this is an equation that could tell you the slope of that equation at any point on the graph, which is kind of crazy that we can do that. All right, now for a hard one. It won't be unfamiliar. You know how the irritating problems in limits were like the fraction ones and the decimal ones? Well, guess what? That was practice for right now. You were training the whole time. All right, let's check it out. Here's example 3. Now, this time I don't have f of x. I have y equals this, so my directions are find y prime. It still means the same thing. I want to find an equation that would find the slope of this crazy graph at any point using limit, definition, derivative. The good news is you're just kind of a robot right now. You blindly follow this. I'm going to write f of x plus delta x minus f of x over delta x, which is just a fancy way of writing slope at a point. This is the same thing we did in 3.0 with the table and all that stuff. It's just the official way to do it. By the way, if you are freaking out right now and thinking, oh my gosh, if derivatives is half of calculus and this is how bad it is, I'm going to cry the rest of the year. Well, it's 2020, so that's a thing. It's okay to cry. But I do want to tell you, all this hard work we're doing with a limit definite derivative, we are going to learn shortcuts later on. Like I already know what the answer to this is going to be because I've done a lot of these. But you'll be able to do these problems in about like 30 seconds each or less. But the bad news is right now we got to kind of do it the hard way. Just know there's hope for the future. These problems get easier. Okay, so now I got to step-by-step fill in each part. If you want to right now, let's do the easy stuff. Like I want to write the delta x on bottom. I want to write this thing at the back, so I'm going to do minus f of x, where I literally copy down whatever the equation is, right? And then the front part, I'm going to plug in an x plus delta x anywhere I see an x in the original problem. So it's still 1 over, right? Imagine if there was a 2 there. You would plug a 2 plus 5 and make it 1 over 7. But it's not a 2. It's much uglier. It's x plus delta x plus 5. Okay. Wow, we're right here. This is a problem. I may have given you this problem or something just like it when we did limits. Because if I plug in a 0 here, I have 1 over x plus 5 minus 1 over x plus 5 over 0. So you have 0 over 0. So I got to do something. The something is the same something you would do anytime you had a fraction problem. Remember what that was? Make common denominators and smash these together. And in the end, instead of dividing by delta x over 1, I'm going to multiply by its reciprocal. So all that work we did before was just training. Training for this moment. Oh, it's intense. All right, so let's find a common denominator. It's going to be ugly, but it's going to be okay. Now, remember, when in doubt, just multiply them together. So my denominator is going to be ugly, and that's okay. Right? I just multiply them together. Boom. Okay. Now you talk to yourself. You say, self, yes. What did I do to the bottom to make it from there to there? Well, Kevin, you multiplied it by x plus 5. Oh, did I? Okay. Whatever you do to the bottom, you better do the top. Will do. It's good to talk to yourself. All right, same deal here. Self, I'm still here, Kevin. What did you do to the bottom to make it look like that? Well, I multiplied by this ugly thing. So multiply the top. Oh, you're full of great ideas today, Kevin. Thank you, Kevin. All right. It's been a day, you know. All right, so now, man, this is ugly. It's looking very scary right now. but it gets better real fast. You've done the hard part. Now that you've gotten common denominators, however ugly they are, don't worry about that fact. You can now subtract them, but don't be a rookie, please. Don't be a rookie. Make sure that this minus sign goes to all the pieces behind it. Okay? Be very careful in that. Or else stuff won't cancel. And if you get to a problem and stuff isn't canceling, once again, you done messed up. All right, so I have minus x. I have minus delta x. And I have minus 5. This is good news because, what do you notice? This x cancels with the minus x. This 5 cancels with a minus 5. And what is left on top? Nothing more than a negative delta x, not a delta x, over ugly thing. Right? And it's still over delta x over 1. Now the last step is to say, instead of dividing this ugly thing by delta x over 1, I could bring it up and multiply by its reciprocal. So that's going to be my move right now. You don't have to write it out in a separate step if you don't want. But I wanted to write it out just this time because of the notes. Times 1 over delta x. Because dividing by a fraction is the same as multiplying by its reciprocal. And now, bottom cancels with that, and you have a negative 1 on top. Don't miss that negative sign. A lot of people miss that. And you have x plus delta x plus 5. And you have x plus 5. Finally, we got stuff to cancel, so now I can plug a 0 in for delta x. And only delta x. And I'm left with negative 1 over x plus 5 times x plus 5. You could write that a little nicer. Remember our equation started out as y equals. So this guy stands for the slope. So you're going to write y prime equals negative 1 over this guy squared. That is crazy. That is the slope of this weird looking graph. You should graph it on your calculator if you don't know what it looks like. That's the slope of this weird looking graph at any point you feel like. So if I want to know what's the slope at x equals 2, well, at x equals 2, the slope of this graph is negative 1 over 2 plus 5 squared. So negative 1 over 49. The slope is negative 1/49th at that point. Isn't that crazy? I think so. All right. Anyway, that's that. The next lesson is easier because, well, it's not easier. The second half, you do all these steps, same exact steps, and then I take it one step further, and we use our answer for something. By the way, a fraction problem, you have to know the fraction thing. Guess what would have happened if I had an equation like this? Guess what would have happened? It ends up looking like, when you do limit, definition, derivative, it ends up looking like all those nasty fraction problems. So all that stuff you did before, it's not going away, first of all. So if you didn't learn it before, well, now's the time. And the second part is, if you did learn it before, this stuff's actually not bad. All right, that's it for now. See you tomorrow. Later.